Testing. Hello, students. So this is our introductory video to PLC programming using FluidSIM, right? So we'll be designing PLCs and programming them in FluidSIM, right? So the softwares we'll be using here are CODESYS and FluidSIM, right? So we'll be using FluidSIM to develop the PLC circuit, and also the pneumatic system that we want to control using the code. And then we'll be using CODESYS to write the code that's going to be executed on our PLC, right? So before we get started, I'd like to go over the background of PLCs, right? So PLC, like, it can be seen as a microprocessor controller that uses the stored instructions in programmable memory to implement logic, sequence, and timing and arithmetic control functions for controlling machines and processes, right? So basically what this means is a PLC, it's sort of like a computer, right? Where you write your code and then it stores that code, and then when that code is executed, like, it can be used to control systems, like particularly in automation, right? So let's say, for example, your sensors may be your inputs, and then your outputs may be, let's say, maybe a pump or a conveyor belt, right? But yeah, or lights, yeah, right. So, like, it uses the inputs of the sensors to trigger the outputs, right? So now this is what a PLC like normally looks like, right? So this is a PLC. It's normally connected to a power supply, right? But there are different kinds of PLC. For like an industrial grade like PLC, maybe, let's say, in automotive, like Ford or BM, right? For they have very large stations, right? So their PLC may be as large as this one right here, right? And then, like, these are other types of modern PLCs similar to this one, and also this one, right? So these are other designs of PLC. So what I want you to know here is that PLCs don't like all look the same. They look different, right? Sometimes you may not recognize the PLC, but then in actual fact, you might find out that it actually is, right. But these are the main, like, designs of PLCs, right? So as I said, like, the key components of the PLC consist of an inputs, right? So inputs, outputs, sorry. So inputs, right? So, like, inputs, like, things like sensors, whatnot. So, like, sensors, they are the ones that send, like, the signal to the PLC when they are triggered, right? And then, like, it has output modules. Output modules are coming from the PLC, going out to those outputs, such as a conveyor belt, right? So an input is received from the sensor, right? And then the PLC sends a signal to whatever output that you want to trigger with that sensor, right? So, for example, like, if you look at this here, this is I 1, 2, 3, 4, 5, 6. So this side is input, right? And then this side, this is the output side, right? Yeah, similar to here, inputs this side, outputs on the other side, right? And then the second part is the central processing unit, right? Which is basically the brain of the computer, right? So as I said, like, a PLC, it's sort of like a computer, right? So how it works is that, like, that computer is used to store the signals and also help execute them, right? Similarly to how a computer works, right? And then the other part, like, as I said, like, a PLC is always connected to a power supply, right? So that it can receive power, right? So a computer cannot function without power, obvious. And then programming device, right? So this, for example, it might be your laptop or computer where you are writing your code at, right? So yeah, so it may be your laptop where you write your code, like ladder logic, structure text, function block, whatever language you are using, right? So that's your programming device, right? And then, like, this is basically the what you call the working operations of the PLC, right? So as you said, like, after you are done writing your code, you have to download it, right? And then after you download it, the PLC scans those inputs, right? after it scans out input, like it waits like for like the inputs to be triggered or for you to execute an action, right? And then like after a signal is received, right? Like, and then if like a particular sensor is triggered or particular sensors are triggered, right? It executes an output, right? Yeah. So, and then as I was saying, like there are also different kinds of programming languages. We've gone over some of these programming languages, right, in class, right? So ladder logic, I'm sure you're familiar with how ladder logic works, and then function blocks, right? Structured text, and then instructions list, right? So now, as I said, so like now, this is an example of input. So it may be a push button, an emergency stop, right? So this the red one is a stop push button. The other one it's a start push button. This is an emergency stop, right? So yeah, according to international standards, right? In your code, right, you have to use the stop button, but you also have to use the emergency stop, right? So the emergency stop, it sort of like cuts the what you call. So let's say for example, right, you you are trying to actuate a cylinder, right, and then use a start and a stop push button, right? But let's say you have a bistable 5-way, right? In your use of a bistable 5-way, right, your cylinder is gonna fully actuate, right? It's gonna feel like even if you press the stop push button, since the signal is flashed, it doesn't need like power to be cut, right? So that it moves to the other side. But emergency stop will stop the cylinder from advancing at that instant, right? So like I want you to what you call I want you to go over and research like why is what you call emergency push button used, right? So it's very important, right? And then this is also inputs, right? So these are the other different kinds of inputs, right? So this is an inductive sensor, a laser sensor, photoelectric sensor, a limit switch, which I'm sure you're familiar with, magnetic proximity sensor, which I'm also sure you're familiar with, and another capacitive proximity sensor, right? So yeah, these are the different kinds of sensors, right? But that there are more sensors, obviously, but like yeah, so this is just an example of sensors that I use, but there's more, right? So if you want to find out about them, you should also like do research, right? So outputs, right? Yeah, as I said, there are conveyor belts, cylinders, motors, and pumps, right? So they get triggered by these inputs, right? And these ones, right? And then now I think we are ready to what you call to start our exercises, right? So now I've opened FluidSIM, right? So I'm gonna open CODESYS, right? So this is the configuration part, right? So you just open your CODESYS. So now, okay, while CODESYS is loading, right? I want us to what you call I want us to go over this, right? So initially, I want to take you through PLC design, right? So now, designing our PLCs, right? We have to first get our outputs, right? So it's open, right? But we'll come back to it later, right? So now, what I want you to do, right, is that like I want you to build your I want to show you how to build and configure your what you call your PLC, right? So your PLC, like you go to EasyPort OPC DDE, right? And then you get your output here, right? So I'm just gonna put it on this side, right? So this is your PLC, right? So this might be somewhat like tricky for you guys, I mean, but like this side where it's written out, this is where you put your input, and then in it's your outputs, right? So I want you to remember that, right? And then now, since now we have our PLC, right? As I said, like one of the elements of PLC is power, right? So you have to supply power to the PLC, right? So this is power, right? Okay. And then we have to get our ground as well. So now we can supply our PLC with power, right? And then now, like as I said, when you're designing your PLC, right, you always need to have, let's say, a start push button so that you can start the process, right? So a start push button, it's what you call, you want to be using like a push button that's not latched, right? We're going to latch the signal using our code, right? So this is our start push button. So we connect it to power, right? And then let's say PP start, right? So, and then move this to the side, right? So just to create like some space, because we want to be loading a lot of components, right? And that's to move our push button to the side like this, right? So this is our start push button, right? And then the same thing that we need, right? As I said, we need a stop push button, right? So as you said, like a stop push button, like it's always normally closed, right? Then up until you press it and then it cuts the power, then it goes back to its normally closed position, right? So in this regard, you want to be using this push button here, right? So you connect it to power, right? And then you connect it back to here, right? And then you want to label this like stop PB, right? And then, okay, yeah. So like while we're doing this, like I want us to ensure that like we don't make sloppy connections, right? Okay. So now, like if I can just demonstrate, right? So as you can see, but this it's normally closed. As you can see, it's allowing power to flow to one, right? But it cuts for less power continue flowing through. So like this is your stop push button always has to be like this, right? And then now after that, right? So let's say we are building like a simple circuit, right? So let me just get a single acting cylinder, right? And then a what you call a solenoid 532A, right? That's normally closed, right? So you connect it like this, right? And then now if I can get my air service units, because you always have to supply air to the system, right? So air service unit, and then I'll compress, which we connect to our service unit, right? So let's say we label this output as Q0, right? And then now we need to get a solenoid valve, right, to be the output, right? So this indicates a physical connection between this and this, right? So now we have to also label this as our Q0, right, which is our output, right? So this is our output because we are using like this. When it gets triggered, right, it's gonna activate the cylinder to go forward or backwards, right, depending on what you want, right? So now after you are done with this, right, I want you to what you call to double to go to what you call to go to options, right? So this is part of configuration, and then I want you to go to easy port didactic connection, right? And then here I want you to go to OPC mode, right? And then after you go to OPC mode, you get something like this, right? So after you get something, so as you can see, like this has changed, right? And then now we're configuring it, right? So now we will go here, right? So here, this is our output, right? Or our input in case, right? So if you still remember from what you call from our CODESYS and Zeros programming, right? Our inputs. So this is gonna be our input side. Our inputs, right? It's EBs, right? So now here we're gonna come here, then we're gonna browse, and then it's gonna load something like this, right? And then we wanna go to Visual PLC, right? And then like here, right, you wanna just select on maybe AP1, right? But now our input, as I said, like they're EPs, right? So here we'll say EP 0 like this, right? And then we'll press OK, right? So now we've configured this side as our EP, right? So it's Visual PLC EP0, right? Then now we configure our output. So how we do that is that we double here, and then we come to this side, right? And then we go to what you call, we go to Visual PLC again, and then we select AP1, right? But since I want to use port 0, like I'm gonna change this one here to 0, right? And then okay, right? And then now so now like we're done configuring our what you call our FluidSIM, right? We wanna go to CODESYS now, right? So under CODESYS, right, you go to new project, right? And then you select your standard project, right? And then here you're gonna label it whatever you want to label it. Doesn't really matter much, right? And after you label it, right, here under you wanna have something like this, right? Under your device, you have to make sure that you have CODESYS WinV3, right? And then here you want to have ladder logic, right? You want to be using ladder logic this time, right? So, but depending on which programming language like you want, right? Or you want to program with, right? You're going to choose the one you want. So, like one thing I'd also like you to do, right? I want you to try this in structured text, right? But anyway, so now after you press OK, this is going to load, right? And then you want to go here, right? So since we're doing it in a simulation environment, right? We're going to come here and activate simulation, right? And then something like this is going to show up, right? And then you want to go to application, right? And then you want to add objects. You want to add your symbol configuration, right? So now it's just symbol configuration, and then you want to load where you want to write your code, right? So now here, like this is where you want to write your inputs, right? And then I'm going to leave this side here to outputs, right? And then now if we come back here, right, to our FluidSIM, right, since we are configured our inputs as EP0, right? So like now when we are writing this like this here, so when I say okay, so if I go back again, so our start push button is connected to port 0, right? And then our stop push button is connected to port 1, right? So now how we label this, right? So our I0 is gonna be our start push button, right? So our I0 is gonna be add shift percentage IX 0.0 and then pull semicolon, right? And then it's gonna be our PB start, right? And then our I1, right, is gonna be at percentage IX 0.1, right? And then pull semicolon stop PB, right? So I want you to what I want you to notice, right? So let me just fix this before I go any further, right? So what I want you to notice that I label my input as 0 point something, right? It's because like I want you, this is very important. I label my input as 000, right? Because like here So so here it's because here like I configured my EP as 0, right? If I configured it as 1, I was gonna write like 1 point something, right? And then yeah, so like this input 1, this input 2, right? And then since currently these are the inputs that we have, right? We want to now come to our output, right? Which is we only have one output, right? And if you also check, we configured this output to 0 as well, right? So which is our Q0, right? So it's configured to AP0, right? Which means we're gonna use 0 point something, right? So it's gonna be Q at percentage sign IX 0.0 full, and then this is gonna be like our, let's say our solenoid 1, right? So it's supposed to be percentage sign, right? So now you are done like inputting your all of your inputs, right? So you come back to simple configuration and you build, right? And then you select all of these, right? And then you go to settings, right? And then you enable direct IO access, right? Then after you've enabled direct IO access, right? You build again, right? And then you come back to your code, right? And then before you simulate, right, I want you to press play here, right? Then after you press play here, you come back to your CODESYS, right? And then you log in, right? And then you say yes, and then you press play, right? And then like this pop-up is gonna show up on your screen, right? And then you come and check on it, right? So for you to ensure that you have properly established a connection, right? So you have to say from FluidSIM, right, through virtual controller to CODESYS, right? So this is the part you're supposed to look at, right? So now if your OPC says here one line connected, and then your CODESYS it's saying connected to localhost, and then the virtual controller is like connected, you have successfully established a connection, right? So now we can write our code, right? So now, for example, right, let's say like I want to say like, so now if I press this, the outputs are not receiving any signal, right? So now let's say if I want to say like if send that to advance, which means I have to send a signal to Q0, right? Using I0, right? So if I come here, right, then I would say what you call, then I would say like I0, which is my start push button, right? So I'd say I0, I want to use it to trigger my Q0, right? And then now I log in, right? And then I log in with download, right? And now I press play, right? And then if I can just view this in two screens. Okay, no. It's proving to be quite the challenge. So, okay. So now, since I've written my code, that's instant to Q0, right? So here, so when I do this, I'm just gonna reduce this. It might be difficult to see, right? So now, if as you can see, the signal is going to Q0 now, right? And this pops, right? And then as you can see, your I1 is always true, right? And then even here, right, when I press here, as you can see, your Q0 does become, as soon as I let go, like the signal goes back, right? Due to this spring load, right, of both the cylinder and the what you call and the three-way, right? So now to make sure that if like let's say now I want to press the signal, I want to press the push button so I can maintain the signal, right? I have to latch the circuit, right? Which means now I have to stop the simulation, right? Okay. So now I stop the simulation, right? And then now I latch the signal, right? So how I latch the signal is that I latch it using my output, right? So I insert my output like this, right? And then I put my Q0 here, right? And then now when I integrate our stop button, so I'm able to cut the power going to the circuit, right? And if you still remember, okay, like from when we're doing ladder logic, right? You always have to connect your stop button in series to every letter, right? So like now, if I put my I1 here like this, right, it's gonna, since it's normally closed, right, it's always gonna allow current to go to Q0, right, up until a point where I need to cut the power, right? So when I cut the power, that when like that push button like only opens up for an instant and then closes, right? So now you might be asking yourself, right, why didn't I negate this stop push button, right? So the reason why I didn't negate that stop push button, right, it's because now since our stop push button is normally closed, right, it means like it's always on like this, right? If I press I0, current will flow to Q0, right, and then Q0 will be actuated. But if I negate it, I'm converting it to a normally open, right? So when I convert it to a normally open, which means it's gonna always be off, right? Which is like when you press the push button now, car is not gonna go to Q0, right? So that's why it's not negated, right? So I hope you understood that, right? So now after you are done, like you log in, right? And then you log in with download, right? And then now okay, so now since I've left the circuit, right, I'm only gonna press this once. Oh, sorry, I forgot to play. So I'm just gonna come here to play, right, and then go back, right? So now if I press this once, the cylinder now remains in the advanced position, right? Because Q0 is on, it's allowing power, right? So now if I want to cut the power, maybe let's say I want to make cylinder retract, right? Can just this in the cylinder retract, right? It stays advanced because of the ledge that I've created on this side, right? So now this is how you, like, these are like sort of like an introduction to PLC programming using PLC, right? So in the next video, right, we'll be looking at some more like advanced circuits, right? So now I think like for this video we're gonna stop here, and then from the next video we're gonna start on exercise 1, right?